Hey guys, I'm going to go over how to take the chemical formulas that I showed you how to write and put into a chemical equation and then balance that equation. So what I have here is a reaction in paragraph form. Okay, and it tells me that calcium nitrate reacts with sodium bromide to produce calcium bromide and sodium nitrate. So what I need to do is start by writing chemical formulas for the substances that are present. I have calcium nitrate reacting with sodium bromide, and those guys are going to be added together to produce calcium bromide and sodium nitrate. So first things first, I would go and write my chemical formulas for calcium nitrate, sodium bromide, and sodium nitrate. If you're not sure how to write the chemical formulas, you can watch my video over that first. But if you do know how to write them, you're going to end up with calcium nitrate, which is CaNO3, sodium bromide, which is NaBr, calcium bromide, which is CaBr2, and sodium nitrate, which is NaNO3. So if I put these guys into equation form, I'm going to put the thing that reacts with the other thing on the left side of the equation, like this. And then I'm going to put an arrow where it says to produce. And then my product side will include the last two pieces, which is calcium bromide, CaBr2, and sodium nitrate. Okay, so my equation is written. Now I just have to balance it. To balance it, I need to make sure that I have the same number of ions on this side of the arrow as I do on the other side of the arrow. I have to use my subscripts to help me count them. And what I want to point out here is that we are not counting elements, we are counting ions as a whole. So when we're looking at nitrate, rather than counting N separately from O, we are actually going to count the entire ion, which is NO3. So if I look at this side, I have one calcium ion, and on the other side, I have one calcium ion. I know that because there's no subscript on calcium, which tells me I have one calcium. My nitrate, which I'm going to look at next, I have two on this side because of that subscript. On the other side, because there's no subscript on nitrate other than the one that's part of nitrate, I know I have one, which means I need to double the nitrate up on the other side. The way that I'm going to do that is I'm going to put a 2 in front of the entire compound. The 2 has to go in front of the compound. There's nowhere else it can go. You can't put it in between the 2 and only affect the nitrate. You have to affect the entire compound that contains the nitrate. So by doing that, I can change this to a 2, and my nitrates are equivalent. Next, I'm going to look at my sodium. On this side, no subscript, that tells me I have one sodium. Over here, no subscript, but I have to multiply the sodium by the 2 that I just put in the front. So that tells me I now need to double this sodium to match that one. So I'm going to throw a 2 on the front of that entire compound, and it's going to affect both the sodium and the bromide. Okay, bromide is the last thing I need to look at, so Br, I have 2 of those. over here, and on this side, because of the subscript, I have 2. So this is my balanced equation. Once it's balanced, I can remove all these notes from the bottom because it can be kind of confusing. And my final answer should look like that. I'd just like to note that this number that we put in the front to help us balance the equation has 2 names, and you might hear it referred to as either one in your book, so I want to make sure that you understand both terms. That can be called the coefficient. It can also be called the mole ratio, because what it does is it helps us to compare each of the pieces of the reaction, so each of the reactants and each of the products to each other in terms of moles. We talked about moles last week. Moles represent a number, so they represent a very large number that we're able to write in smaller form. So basically this just helps us to compare quantities of things in the chemical reaction.